Hi friends, in this video we are going to learn about the power factor improvement from VK Mehta BOOK. Before starting this video, please do subscribe this YouTube channel, Engineering Knowledge, and press the bell icon to get more updates. Power factor can be defined as the cosine of angle between voltage and current in an AC circuit is known as power factor. Now let's see power triangle. Here picture is given. The analysis of power factor can also be made in terms of power drawn by the AC circuit. From the figure we can see, OA is equal to VI cos phi, and represents the active power in watts or kW. AB is equal to VI sin phi, and represents the reactive power in VAR or kVAR. OB is equal to VI, and represents the apparent power in VA or K versus A. The following points may be noted form the power triangle, that is. Number 1 is the apparent power in an AC circuit has two components, active and reactive power at right angles to each other. Apparent power square is equal to square of active power plus square of reactive power. Number 2 is power factor of a circuit may also be defined as the ratio of active power to the apparent power. Number 3 is the lagging reactive power is responsible for the low power factor. Smaller the reactive power component, the higher is the power factor. For leading currents, the power triangle becomes reversed. If a device taking leading reactive power example is capacitor that is connected in parallel with the load, then the lagging reactive power of the load will be partly neutralized, thus improving the power factor of the load. Power factor definitions are given as. Definition number 1 is, it is defined as the cosine of angle between V and I. Definition number 2 is, it is defined as the ratio of resistance to impedance. Definition number 3 is, it is defined as the ratio of active power to apparent power. Disadvantages of low power factor are given as large kVA rating of equipment, greater conductor size, large copper losses, poor voltage regulation, reduced handling capacity of system. The causes of low power factor are given as most of the AC motors are of induction type, either single-phase and three-phase induction motors, which have low lagging power factor. Arc lamps, electric discharge lamps and industrial heating furnaces operate at low lagging power factor. The load on the power system is varying. During low load period, supply voltage increased, which increases the magnetization current, hence decreased in power factor. Power factor improvement can be done by following terms. To improve the power factor, some device taking leading power should be connected in parallel with the load. One of such devices can be a capacitor. The capacitor draws a leading current and partly or completely neutralizes the lagging reactive component of load current. This raises the power factor of the load. There are 3 types of power factor improvement equipments. Number 1 is static capacitors. Number 2 is synchronous condenser. Number 3 is phase advancers. The static capacitor can be defined as by connecting capacitors in parallel with the equipment operating at lagging power factor can be improved. Capacitor draws a leading current and partly or completely neutralizes the lagging reactive component of load current. Figure shows the star and delta combination of static capacitor. The advantages of static capacitor are given as low losses, require little maintenance, easily installed, light in weight, require no foundation, work under ordinary atmospheric conditions. The disadvantages of static capacitor are given as having short service life ranging from 8 to 10 years. It easily damaged if the voltage exceeds the rated value. If capacitors are damaged, their repair is uneconomical. The synchronous condenser can be defined as synchronous motor takes a leading current when overexcited and, therefore, behaves as a capacitor. An overexcited synchronous motor running on no load is known as synchronous condenser. Machine is connected in parallel with the supply. It takes a leading current which partly neutralizes the lagging reactive component of the load. The advantages of synchronous condenser are given as by varying the field excitation, the magnitude of current drawn by STHE motor can be changed by any amount. This helps in achieving steepless control of power factor. Motor windings have high thermal stability to short circuit currents. Faults can be removed easily. The disadvantages of synchronous condenser are given as considerable losses in the motor, high maintenance, produces noise. Except in sizes above 500 kVA, the cost is greater than that of static capacitors of the same rating. Synchronous motor has no self-starting torque, so auxiliary equipment has to be provided. The phase advancer is defined as. It is used to improve the power factor of induction motors. The phase advancer is mounted on the shaft as the main motor and is connected in the rotor circuit of the motor. It provides exciting ampere turns to the rotor circuit at slip frequency. The induction motor can be made to operate on leading power factor like an over-excited synchronous motor. The advantages of phase advancer are: as the exciting ampere turns are supplied at slip frequency, therefore, lagging reactive power drawn by the motor are considerably reduced. It can be conveniently used where the use of synchronous motors is inadmissible. The disadvantage of phase advancer is they are not economical for motors below 200 horsepower. Importance of power factor improvement is, for consumers' point of view, improvement of power factor to a proper value results in the net annual saving for the consumer. If the consumer improves the power factor, then there is a reduction in his maximum kVA demand. And for generating station side, as station output is kW equal to kVA cos phi, therefore, number of units supplied by it depends upon the power factor. The greater the power factor of the generating station, the higher is the kilowatt-hour it delivers to the system. Most economical power factor can be defined as the value to which the power factor should be improved so as to have maximum net annual saving is known as the most economical power factor. It is the main formula. To meet the increased kilowatt demand on power stations, we have mainly two methods. First one is by increasing the kVA capacity of the power station at the same power factor, but it requires extra cost. And the second is by improving the power factor of the station, it also involve extra cost. Thanks you so much for watching this video. Hope you enjoyed this video. Please like, share, and do subscribe this YouTube channel, Engineering Knowledge, and press the bell icon to get more updates.